Hey, I'm Lucas Tyler.
Hey, I'm Elliot Schaan.
We did our project on fluid dynamics. What is fluid dynamics, you might ask? Fluid dynamics is a branch of fluid mechanics that deals with the natural science of liquid and gases in motion.
Boom. There it is. Some topics we'll be kind of exploring today are viscosity. We'll do some things with capillarity too. We'll see. And aerodynamics to finish us off. So it's gonna be a fun one. Let's do it.
So fluid mechanics, different than fluid dynamics, is the branch of physics that studies fluids such as liquids, gases, and plasmas, and the forces on those fluids. Fluid mechanics can be divided into fluid statics, fluid kinematics, and fluid dynamics. We are focusing on fluid dynamics, which is the study of the effect of forces on fluid motion.
Viscosity, the state of being thick or semi-fluid in consistency due to internal friction. Alright students, right now we are going to try to demonstrate viscosity and how it works. So we're going to take some syrup, got some right here, some really good stuff I think. Oh, there it goes. Alright, got some syrup on there, right? We're going to grab some dressing here. And probably try not to spill this one. Oh, there it goes. Alright, we got some dressing. And then finally we got some mustard. Now we're going to tip this over, and the speed in which it moves down this cardboard is going to determine, that kind of demonstrates the viscosity. The thicker the viscosity, or the more viscosity it has, the slower it's going to move. Dr. Elliot here, and I got some stuff on here. So the higher the viscosity, the slower it's going to move when I tilt this. Ready? Syrup got a head start, but I'm still going to tip it over. Ready? Oh, look at that syrup go. Oh, look, it's going.
Fluid dynamics is an active field of research with many unsolved or partly solved problems, and also the reason why we're not going to have many equations in this video. The math in fluid dynamics is very complicated, but it does involve calculating various properties of fluid such as velocity, pressure, density, and temperature.
Capillarity. It is the tendency of a liquid in a capillary tube or absorbent material to rise or fall as a result of surface tension.
Go.
Alright, Professor Elliot here again. So I got a paper towel that I rolled up. This is going to symbolize how capillarity works. So I'm going to put this in this full cup of water right here, and this one has no water in it, so I'm going to dip this side in here. I'm going to put this one over on that side, and eventually the water will travel up the paper towel and into the empty cup. Alright, so as you can see, we waited about 37 days. And when we come back, I'm just kidding, it was like 5 minutes, but you can come back, come take a look at this. So the water traveled up the paper towel in capillary tubes, which is how it was acting, and it deposits itself over here on the other side. Pretty neat, huh?
Fluid dynamics is based on a couple of laws, such as the conservation laws, specifically conservation of mass, conservation of linear momentum, and conservation of energy. Fluids follow this continuum assumption, which means they're always continuous and always moving. So then, the properties such as density, pressure, temperature, and velocity are incredibly small points, and they vary widely from one point to another.
Aerodynamics, the study of the properties of moving air, especially the interaction between air and solid bodies moving through it.
Alright, so study of aerodynamics is how objects move through the air. So another example is this frisbee, because when you throw the frisbee flat, it really cuts through the air and it's really aerodynamic. But when you throw it kind of lopsided and it gets all topsy-turvy, and then the air catches up with it and kind of makes it flop around and not go as far.
Dude. Oh yeah, look at that thing go. Boom.